going to show you how Armory Continuous Deployment as a Service helps you scale your deployments by orchestrating the deployment promotion lifecycle across all environments and clusters, even when deploying using an operator like Argo rollouts, and including rollbacks. Cross-environment orchestration for Argo that you don't have to spend time building. Historically, deploying software has involved downtime and complicated, time-consuming, and error-prone processes to minimize the possibility of breaking anything, often referred to as the blast radius. The impact of missing even a small issue could result in an outage, causing a poor customer experience or, worse, a lost customer. Armory Continuous Deployment as a Service delivers declarative deployments that support progressive delivery strategies so developers can focus on building great code rather than deploying it. By automating code deployment across all environments, CD as a Service removes demands on developers, as well as reduces the risk of service disruptions due to change failures. It does this by seamlessly integrating pre-production verification tasks with progressive deployment strategies in production. And CD as a Service doesn't require migrating to a new CI/CD platform. It plugs easily into any existing SDLC. Armory Continuous Deployment as a Service is available as a GitHub action and as a CLI, which can then be called from any of your existing tools like Jenkins, TeamCity, or other in-house tools. Here I am in the Argo Rollouts UI. As you can see, it shows me the state of my rollout object within a single cluster. Now let's go start a deployment using Armory Continuous Deployment as a Service that will validate my application and staging before finally updating this rollout. I'm going to start a deployment by running the CLI from a checkout of my Git repository, passing it the definition of my deployment. Armory starts my deployment and provides me with a URL that I can use to view and interact with my deployment. Here, I can see a high-level overview of how my code is reaching each of my environments. As you can see, my development environment is currently updating. Once it finishes, InfoSec and staging will update, followed by production environments. All environments except the production environments are using a simple rolling update. Once staging is deployed, it will trigger a webhook, starting my integration tests within GitHub Actions. The production environments will only be deployed if these tests pass. Webhooks can be leveraged to integrate all your existing automation into your deployment. Similarly, InfoSec is running a security scanner in GitHub Actions that must pass before production is deployed. Once they finish, the production environments will wait for manual approval before deploying. In addition to deploying standard Kubernetes manifests, Armory can deploy CRDs. If those CRDs are for operators, Armory can also wait for the operator to finish its deployment before proceeding. Let me show you how this works using Argo rollouts. In this case, we deploy the CRD, we then monitor Kubernetes to wait for the operator to finish deploying the infrastructure managed by the CRD. Let's go look at the Argo Rollouts UI while it finishes its deployment. This rollout is deploying with the Canary strategy, and only progresses when I click Promote. Each time it pauses, I'm going to click Promote to continue. As you can see, CD as a Service only considers that environment complete after the operator finishes deploying. This allows you to orchestrate your software releases across multiple environments using CD as a Service, even when you are using an operator within an environment. If you are not using an operator, Armory CD as a Service provides advanced deployment strategies to minimize risk. My 3 additional production environments are each leveraging different advanced strategies to minimize the risk of their deployments. Now that the other environments are deployed, let's approve our prod EU environment's deployment. This environment is using a blue-green deployment strategy. We can click into the environment for more detail on how its deployment is progressing. The environment-specific status UI is split into 2. On the left, you can see a high-level overview of what's going on with your deployment. This shows me the current status, and I can see that the green version has been deployed, and we're now about to begin running an automated analysis on it. On the right-hand side, I can see more detailed information, such as that there are 2 different microservices being deployed together in the application. The blue version just stopped receiving 100% of traffic as it redirected to the green version. We just ran an automated Canary analysis that checked our monitoring in Prometheus to see if there were any errors, and it passed. We also used a webhook in order to kick off some custom automation that checked our logs for errors. Right now, we are waiting for approval to continue with the deployment. Until this manual approval is issued, the old version of the application will continue to be kept around so that we have instantaneous rollbacks. Everything looks good, so I'm going to go ahead and approve this deployment to finish. My blue-green strategy just shut down the old version, finishing my deployment. Let's take a look at the other production environments which are using a Canary strategy. A canary strategy is a controlled process allowing you to gradually deploy a new version of code and incrementally increase the percentage of traffic reaching it. We support two methods of routing canary traffic to the new version. In this case, the new version is getting 25% of traffic by scaling different numbers of pods for different versions. In the details on the right, you can watch the pods scale up and down as our deployment processes. This allows you to implement a canary strategy for any cluster, but for certain applications may be slow since each pod scales independently. Alternatively, we also support traffic management via SMI-compliant service meshes like Linkerd. Let's see what that looks like. Here we are using a service mesh to redirect traffic between the two versions without having to control the number of pods, and ensuring the accurate traffic split between those two versions. This allows us to send as little as 1% of production traffic to the new version, regardless of how many pods it uses. At this point, we are running an automated canary analysis against our metric provider. When it passes, we will also check our logs for errors. When both pass, the traffic will scale to the next step, which is 50%. The deployment is now running an automated analysis which has been configured to fail. We can see that the automated analysis failed because a particular metric exceeded its thresholds. We can also see the specific metric values as well as the query that came back from the metric provider, in this case Prometheus. If desired, we can easily roll this environment back to the prior version to mitigate any risk of our new application version. When I roll back, Armory Continuous Deployment as a Service restores the old version to full capacity and sends 100% of the traffic to it. Once the old version is handling all traffic, the new version spins back down, and with that, my production environment is fully rolled back, and any negative impact of my deployment has been mitigated. In addition to rolling back the current environment, we will also roll back any other currently in progress environments and cancel deployment to any environments that have not yet started. Throughout this demo, every manual step that I have done can also be fully automated. For example, canary analysis can be set to automatically roll back instead of waiting for a manual approval. That is the core functionality offered by Continuous Deployment as a Service. Now let's take a look at how this is configured. The deployment configuration is defined in a YAML format. Here we have specified the name of the application to which we are deploying, and here we have specified the list of environments to which we are deploying. Each environment specifies what Kubernetes account is hosting it, as well as the rules for how that environment will deploy. For example, we can see what strategy staging is using, and we can also see that staging has been configured to only deploy after the development environment has finished deploying, and that it is going to run some integration tests via webhook after it finishes deploying. Similarly, if we scroll down to our production environments, we can see that they depend on both the InfoSec and staging environment, and that they are also waiting for a manual approval before they begin deployment. The manifest section specifies what manifests we are deploying. By default, all manifests go to all environment, but if you have environment-specific manifests, such as configuration maps, they can be deployed to only specific environments. The strategies section specifies how environments are deployed. For our canary strategy, we started by sending 25% of traffic to the new version. We then ran an automated canary analysis of this metric. When it passed, we then ran a webhook that checked our logs for errors, and then increased traffic to 50%. Finally, we ran another automated canary analysis, analyzing these two metrics. This canary analysis failed and we rolled back. If we had continued deploying, we would have run our check logs metric again, and then we would have finally finished increasing traffic to 100%. For the blue-green strategy, you can specify one or more constraints that need to pass before traffic will be redirected, and similarly specify one or more constraints that need to pass before we shut down the old version. For the automated canary analysis, these queries are just written in the metric provider query language so you can reuse your existing monitoring. In this case, I've used Prometheus. We also currently support Datadog and New Relic as metric providers. When using an SMI traffic manager for Canary, we define the names of the incoming services from which traffic should be routed. Similar configuration is provided for blue-green deployments in order to expose the new version via preview URL before routing traffic to it. Each webhook definition has a unique name that is used to reference it. The webhooks provide a simple way to call any REST API. Here we specify the URL of the API that we are calling. In this case, we are triggering a GitHub Actions workflow through the GitHub Actions Dispatch API. We are passing our GitHub token in an authorization header to authenticate with GitHub. We read this token from a secure secrets store. Here we are specifying the body of the API call. In this case, it is specifying the name of the GitHub Actions workflow that we are triggering. It also provides a URL to which the GitHub action will call back when it finishes to let our deployment know whether it succeeded or failed. We've shown you Armory Continuous Deployment as a Service, which allows you to simplify deployments to multiple environments, leverage advanced deployment strategies to limit the blast radius, and provide rollbacks as easy as a single click. To give it a try, sign up at go.armory.io/signup.